a dormant volcano. The black hole at the center, at the heart of our galaxy, the Milky Way Galaxy, is more explosive than we thought. This is by Joss Bland Hawthorne, Director, Sydney Institute for Astronomy, University of Sydney, on the conversation. The supermassive black hole at the heart of our galaxy spat out an enormous flare of radiation 3.5 million years ago that would have been clearly visible from our Earth. Can you imagine? In new research that will soon be published in Astrophysical Journal, my colleagues and I found that the flare left traces in the trail of gas called the Magellanic Stream that lies some 200,000 light years away and encircles the Milky Way. Now we have the Magellanic Cloud. You can see that if you're on the south, in the south hemisphere, you can see that. We can't see it because we're in the north, most of us here, but if you're in the south hemisphere, Australia, New Zealand, or South Africa, you can see the pinkish, two pinkish figures in the sky above you. That's the Magellanic Cloud coming at us. Now, the team includes Ralph Sutherland and Brent Grooves at the Australian National University, and Astro 3D, Magda Guglielmo and Wen Hao Lee, and Andrew Curzons at the University of Sydney, Philip Maloney at the University of Colorado, Gerald Cecil at the University of Carolina, and Andrew J. Fox at the Space Telescope Science Institute in Baltimore, Maryland. The discovery changes our view, he says, of our galaxy's central black hole, which has appeared dormant throughout recorded human history. Astronomers are coming to realize that it has been hugely active, even explosive, in the relatively recent past in galactic terms, measured in millions of years, of course. This activity has been flickering on and off for billions of years. We don't understand why this activity is intermittent, but it has something to do with how material gets dumped onto the black hole. It might be like water droplets on a hot plate that sputter and explode chaotically depending on their size. Our situation on Earth resembles living near a largely dormant volcano, like Mount Vesuvius, that is known to have been explosively active in the past, with disastrous consequences for Pompeii. Despite this, there's no need to be alarmed. As far as we can tell, we are safe here in orbit about a cool dwarf star far from the center of the Milky Way. Now, why is there a black hole at the center of the galaxy? If you look along the Milky Way in the direction of the constellation Sagittarius, you'll see the dense agglomeration of stars around the center of the galaxy. The galactic center is marked by a very dense, very massive cluster of stars orbiting the supermassive black hole. Earlier this year, the ESO gravity team found a star close to the black hole, traveling up to 10,000 kilometers per second, a few percent of the speed of light. This let them weigh the black hole to a precision of 1%, arriving at a number of about 4 million times our sun's mass. As galactic supermassive black holes go, this is a featherweight. For example, our neighboring galaxy Andromeda, which we will collide with in about 4.5 billion years, also has a supermassive black hole, but it's 50 times heavier than ours. Essentially, all large galaxies have central massive black holes. We don't know exactly why it's so, but we know it's important and that the growth phases of these monsters are likely to have affected the galaxy as a whole. Understanding the effect of interactions between black holes and host galaxies is one of the hottest topics in modern astrophysics. Some black holes are more active than others, but if we look out across the universe, we see only a few percent of galaxies appear to have active black holes. But by active, we mean that gas and stars spiraling into the black hole form an extremely hot ring of gas. This ring, called the accretion disk, gets so hot that it drives jets, winds, and radiation beams of light out across the galaxy. The effects of these explosions are particularly impressive in more massive galaxies. For decades, Australian radio telescopes have mapped out jet flows that are far larger than the visible galaxy in the middle. The radio jets in the galaxy Centaurus A extends more than 10 degrees across the sky. That's the size of 20 full moons next to each other. This is remarkable given Centaurus A is 10 million light years away. The Milky Way Galaxy, some 3 million years ago, our direct ancestor Australopithecus afarensis walked the Earth. They well may have looked up towards Sagittarius and seen cones of light shooting sideways from the Milky Way brighter than any star in the galaxy. The light show would have appeared as static beams on a human timescale, only flickering on timescales of thousands of years. Today, the only visible remnant of that immensely powerful event is the cooling gas along the distant Magellanic stream. So how would life on Earth have fared if the explosive jet was directed straight at us here to Earth? This is a valid question because we believe that the spin axis of the accretion disk flops around wildly in lightweight supermassive black holes. If the beam was pointing at the solar system, the jet would have to plow through the Milky Way disk, and it would take about 10 million years to reach us. So it's possible that a more ancient explosion could have produced a powerful jet that is yet to reach us. But we need not worry. At this peak, the intensity of the jet when it reaches us is unlikely to exceed the most energetic solar flares. These are known to knock out satellites and pose a threat to spacewalking astronauts, but our own atmosphere largely protects us here on Earth. And this is on The Conversation by Joss Bland Hawthorne, Director, Sydney Institute for Astronomy, University of Sydney. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.